All right, I believe it's recording, yes. Welcome folks to the Bhyve JTD. Just to kind of cover off what I wanted to do in this one, I wanted to first talk a little bit about KVM and QEMU to kind of set the stage to contrast that with Bhyve, which is the new hypervisor that we brought to Illumos and SmartOS. So to kind of step back and take a look at KVM and QEMU, which was the existing hardware virtualization that we have in SmartOS. Work was done, I think, 2011, 2012 to port KVM, which is the kernel virtual machine, and QEMU, which is the quick emulator to run on SmartOS. Just kind of some background on that. QEMU, the quick emulator, is capable really of virtualizing or emulating quite a bit of hardware, other CPUs, x86, a bunch of devices like disks or floppies or network controllers, things of that nature. And when run without hardware acceleration capabilities, like offered on Intel CPUs and things, can emulate CPUs and software. So if you try and start a KVM instance on SmartOS on a machine that doesn't have those hardware capabilities, you will sometimes see it start and succeed and run just consuming a ton of CPU because QEMU is sitting there pretending to be an x86 CPU in software and runs incredibly slowly, but still does run. But that isn't particularly performant. It's quite slow. So fortunately, Intel has added technologies such as BMX, which allows the CPU to kind of help with emulating a system. So KVM, the kernel virtual machine, is started as a Linux kernel module, which interfaces with those facilities for kind of accelerating hardware virtualization for a system. And QEMU can, rather than doing all of its work in terms of emulating a CPU and software, can defer those tasks to KVM. So what does KVM do in this instance? Kind of a lot of the operations for entering the context of emulating a system, emulating a CPU, kind of setting up those structures are all privileged operations on the CPU, so they need to be done in ring 0. So it's a kernel module that kind of exposes that surface of, setting up a CPU context with given registers and given state. It kind of controls all of that and presents an ioctl interface that QEMU or other hypervisors can use to instantiate a vCPU or multiple vCPUs, have them communicate between each other. In addition to that, you kind of originally on older Intel CPUs, it had VMX, which helped with emulating a CPU, but it was kind of still on you, the OS or the hypervisor, to deal with kind of how you maintain this illusion of the guest's memory. So they had to maintain shadow page tables and kind of do all of this work to maintain what looked like the guest to having their own set of physical memory and then virtual memory that the guest could manage on top of that. Kind of early in Intel's development, they added EPT, which is extended page tables, which is a set of page tables much like normal x86 page tables, where those are used to present a virtual memory to a process, say, where it observes a space that looks like a giant linear flat space that it owns, which is really backed by hardware pages that the OS kind of creates this fiction of this virtual address space for a process. That same concept is done in EPT for a VM. So the hypervisor, KVM in this case, can select a bunch of physical pages that it then presents to the guest system, the guest OS, as kind of a linear space of physical pages that guest can use, even if they're scattered all over the system. And then the guest can build on top of that its own virtual address space using standard x86 paging. So it kind of nests that concept of paging. So KVM kind of manages creation of these EPT structures and linking that to the VMX structures. In addition to that, there are a handful of system peripherals that every VM, every system is expecting to be there. Things like the interrupt controllers for the CPU, or the PIT, the interrupt timer, things of that nature that QEMU could theoretically emulate, but that many of those devices are kind of really sensitive in terms of performance. You know, you're going to be using the interrupt controller a lot, and you want the latency for a device like that, you know, sending an interrupt to another CPU or quickly delivering an interrupt to a CPU. You want the latency on those sorts of devices to be kept to a minimum and performance to a maximum. So KVM handles some of that emulation in kernel space, so that if a guest CPU says, you know, indicates that it wants to send an interrupt to another CPU, all of that can be done in kernel space rather than taking a round trip out to user space where QEMU is running to say, hey, someone wrote to this memory address, and then emulating a interrupt controller action, something of that nature. So there are a handful of peripherals that are done in KVM for the purposes of performance, and it kind of makes managing a lot of that state easier to have that all in the kind of in the domain of the kernel module there. So that's kind of like a high-level diagram of how KVM and QEMU work on us. Our KVM, as I mentioned, the port was done a while back. Our KVM is essentially a fork from Linux KVM. We've not continued kind of forward porting patches or updates there. The same goes for QEMU. We've kind of applied certain fixes for security holes that were found in QEMU. But because there was a huge amount of churn in QEMU, particularly because it is QEMU is its scope isn't solely I want to present, you know, an x86 VM. It can emulate ARM, it can emulate Power, it can emulate, you know, dozens and dozens of devices. It's a huge code base. No, I don't have slides, Angela, sorry. So the scope of QEMU is very wide, which was kind of not meeting our goals for, we just want a high performance, stable, secure virtual machine for running tenant workloads. So for that reason, we've not kept up on QEMU updates. As we've kind of fixed things ourselves, our QEMU has drifted. And in terms of capabilities, it's somewhat lacking. There are particularly enhancements made to KVM that we just don't have because our KVM is from, you know, 2012, 2011. So that has been, that among other things, kind of a recurring complaint is poor network performance in our virtual machine. Part of that reason is when if QEMU is emulating a VirtIO net device, and there's kind of a lot of copying data around when a packet arrives for a VM, and it is essentially received in its raw form by the QEMU process into a buffer, and then that is copied, I think, into another buffer, and then copied into the guest memory. So there's a lot of excess copying of data, and kind of a lot of this handling is done in user space in QEMU. So kind of every time you're kind of initiating an action, you're looking at kind of 1 or 2 round trips in and out of kernel space or in and out of user space to get these things done. So that really drives up the latency, and it's why if you run an iPerf test on inside KVM QEMU on SmartOS, you're looking at like tops a gigabit maybe. We can run a test later. I've got some quick demo stuff, and we can kind of play around with that. But network performance wasn't great. Disk performance on us, there's room for improvement there. So overall, the hardware virtualized experience in KVM and QEMU, while it is critical to have to be able to run, to be able to run Linux or FreeBSD or whatever else that you wanted to run in an HVM environment, it's a useful tool to have, but performance wasn't great, which made it a less than popular choice. So a while back, was it a year and a half ago, we learned that Pluribus, kind of an Open Solaris / Illumos company, had done a port of Bhyve, which is the BSD hypervisor, had done a port to their Illumos Open Solaris fork. And we eventually got the source code for that. And kind of one distinction there, one kind of the stated goal of Bhyve wasn't to be this Swiss Army knife of the emulators that could emulate, you know, any system on any system and do all of these devices and that. It was, you know, kind of from the outset, it was, we want a decent hardware virtual machine in Bhyve or in FreeBSD. So it was only AMD 64, only targeting systems that had the EPT, right? They weren't going to play games with shadow page tables and things like that. And kind of a limited scope in terms of devices. The actual, the structure of the software is very similar in terms of there's kind of a kernel module component, again, that interacts with those high privileged things in terms of the VMX instructions and structures where you're interacting with the CPU in that manner, as well as setting up the EPT structures to maintain the fiction of a guest physical address space. And then there is a user space component where things like PCI device emulation, kind of the tasks where ultra low latency or ultra high performance are kind of a lesser concern, where it's, you know, it's a lot easier to do things in user space, and if you screw up, the consequences are lower. So again, there's a user space component which calls into the kernel to do the hardware virtualization tasks, but handles kind of a lot more of the day-to-day stuff in terms of presenting what appears to be PCI devices or things of that nature. So does this kind of, from a high level, this makes sense in terms of why Bhyve and how it's structured, things of that nature? I'm keeping an eye on it if folks have comments there. Good there. So kind of some benefits there. The Bhyve being newer is utilizing, at least on Intel CPUs, kind of utilizing more of the feature set. Intel has done some work to assist in kind of doing hardware virtualization of the interrupt controller, which previously was done kind of all in software in the kernel and in the hypervisor. So that allows things that are, you know, sending a high rate of interrupts or manipulating certain state in the interrupt controller, makes a lot of that faster. I've got kind of a demo to show off some of that. I have some lab machines here, one with that capability, one without. Kind of one other thing I wanted to touch on in terms of one of the frequent comments was network performance. So kind of as part of the code drop that we received from Pluribus, was they also had written a network driver called Viona, which stands for VirtIO Net Accelerated, which was essentially a driver that sat in kernel space that would accelerate a VirtIO Net device. Linux has something kind of similar to this called vHostNet. I think, having looked at that driver, it's kind of more general. There are some, I think it can be adapted to kind of not just do network traffic, but do block or other things. But Viona was kind of very specifically targeted towards kind of processing the VirtIO Net tasks in kernel space and cutting down on some of those round trips. So as part of our porting effort in getting Bhyve from Pluribus, updating it to kind of the latest where FreeBSD was, and then updating and hardening the Viona driver, we hooked that directly into Mac, our in-kernel networking system. So that hooks directly into Mac, which gives us the benefit of, one, we can kind of cut down on the number of copies that we're doing. So for packets that are being received by the guest, it has landed in a buffer from a NIC or from somewhere else. But we only need to copy that once from wherever that buffer was into the guest memory that it has designated for receiving that network packet. And then in terms of transmitting network packets, the guest selects a memory that it wishes to transmit a packet, a frame. And then we can literally hand that physical memory all the way down to a NIC if you know if the DMA stuff is willing. So it really cuts down on the amount of copying that we can do. And when we look at some of the benchmarks, particularly with the work that Ryan Zaseski did in terms of omitting the need to do checksums on loopback and being able to do large segmentation offload, particularly on loopback, where if I'm copying data from one VM to another, is there a reason to chop that up into 1,500 byte MTU packets when I know that they're both on the same machine? We can just move a 64K kind of block of data, which really cuts down on the amount of work that we need to do. So if that sounds all good, I've got some lab machines here. If I can share my desktop. That is maybe visible. It destroyed my thing here. It nuked all my windows. That's awesome. One second. Hello?
Hey, Patrick, I can hear you.
Okay.
I can hear you fine. I'm just seeing black.
Yeah, it nuked my screen. I don't know how I get the host back. Because it hasn't actually dropped that entity from, that's awesome.
Yeah, I see you twice on my screen, Patrick.
Yeah, I dropped and rejoined.
Ah, there we go.
Could I get host back from Joyent Engineer, who's ever signed in there?
We'll do 1 second.
All right, give me 1 second, but I think it's still recording. I'll make you back the host again.
Thank you. Let's hopefully...
You should have it, Patrick.
Yep. This is totally buggered.
I think we're seeing your window manager.
Well, I'm like, it's...
I got green screen now. Oh, wait. No. Oh, almost.
I don't know where... It like blacks out the window when I select it. One second. Sorry about this. Yeah, it literally like paints over the window when I do that. Which this worked before, but it is apparently not working today. I'm sorry, I don't have a demo because Zoom is being shitty.
Full screen doesn't work.
I did full screen. It like wherever it goes to share something, if I select that screen, it paints over the screen with a giant black. Yeah, sorry, this isn't working at all. It just like dickered my session. Sorry, I got nothing. Zoom's totally malfunctioning.
All right, I guess maybe you want to skip the demo, like cover whatever else you want to talk through, and then maybe do a recording, separate recording.
Yeah,
of
I
the
could try and
demo.
do that. You know, without a demo, I don't have a ton else. Unless folks have questions, I'd be happy to. Yeah, it shows both monitors, Zeller, and like I can select a window, but whatever window or monitor that I selected sharing, it goes and paints over total black, and then I can't see shit, which is awesome.
Patrick, do you have any data, like benchmark data comparing KVM versus Bhyve?
Yeah, so kind of going back to network performance as an example, KVM largely would top out at about a gigabit per second, either in or out. For Bhyve on a modern system, I was testing kind of on my newer, I've got a Ivy Bridge machine where doing loopback hyper test, it was like 14 to 17 gigabits a second, which is granted, we're getting all the benefits of large segmentation offload and kind of hardware checksum offload, since the guest essentially indicates that it wants the NIC to do hardware checksumming. And if we're looping that packet back, we just tell whoever the target is that the hardware checksum checks out, because we know that it couldn't have been buggered in transit. So in terms of loopback, I was just playing around with some test data earlier. I got up to 27 gigabit in and out of it was a CentOS 7 VM doing an iPerf test to a kind of a native zone on the machine. So network performance is way up. In terms of other things, Bhyve right now does less of a great job in terms of masking out CPU features, which means that we expose more. It has the downside of if you were to migrate that instance, you might have CPU features that would potentially appear to disappear if you migrated from a newer CPU to an older one. But it does mean that a guest can kind of use more of that. In terms of it, especially when it comes to if we ever implement something akin to live migration for Bhyve, we'll want to look at kind of making that more polished and a better interface for kind of constraining the view of the CPU that the guest has. But we get better performance there. I think at least for one of our customers, it was a big drive to get to Bhyve because their applications running as a guest could leverage a bunch more of what modern CPUs had to offer. Does that cover most of that question?
Sure. I have another one, unless other people have questions, but what are the issues, or what is the thinking about eventually being able to have our current KVM VMs kind of just, can we boot to a new platform and have them start using Bhyve, or is there issues around that transition?
There are a number of issues with that. So kind of one big one is for KVM, the way that we do networking in KVM, because when you provision an instance, you generally assign static IP addresses to the network interfaces on that instance, right? It's going to be Triton is going to say, you're going to receive this IP address. And we needed a way to, in a native zone, we could just kind of inject that information into the zone. For hardware virtualized instances, we needed a different means of doing that. So the way that KVM accomplished that task was that we would just set all of the interfaces in the guest, be it Linux or whatever. We would set all the interfaces to be DHCP. And then QEMU had a little DHCP server built into it that when we fired up the zone that QEMU was running in for that instance, we run QEMU and KVM and Bhyve as well. We run in a zone to kind of constrain their environment. When QEMU would boot up, it would receive the addressing information that was set for that zone. So when the guest would come up and request DHCP addresses for its interfaces, then QEMU could simply answer with the static interface that had been given to the instance, and kind of everything would work out. The guest would get the address it would need. But it did mean that QEMU had to sit there essentially looking at all the traffic that came out of the VM, looking for DHCP requests, right? Kind of adding to the per packet overhead that QEMU had to deal with. For Bhyve, that was kind of much less desirable, especially since we had this kind of fast in-kernel VirtIO.NET thing, and adding a kind of a built-in DHCP server to that would both negatively affect its performance and make it significantly more complicated. So images in Bhyve are expected to query over the metadata service, which is available on a serial port, just like in KVM. Query via the metadata service their static addressing information. So Mike Ertz did work on updating CloudInit, which is the kind of the Linuxy thing that guest images use to configure the guest to run in a cloud-like environment. Added support in CloudInit to query networking information via the metadata service, and then statically assign those addresses onto those interfaces. So now Fiona doesn't have to sit there and look for DHCP packets, but it means that if you take a KVM image and try and run it in Bhyve, all of those all of the NICs in that instance are going to try and sit there and get their address via DHCP, and they're never going to get a response. So that's kind of one issue. Another issue is that the Bhyve isn't. There are means of kind of configuring the PCI addressing, but a lot of that is, I think, the way that we kind of add PCI devices, be it VirtIO block devices or VirtIO NICs, differs from KVM. So I know, like OmniOS, for example, Josh Kalula and company are working on fixing this, but ZFS goes looking for its pool, and if it can't find the devices at precisely the given address on the system in terms of PCI, it throws its hands up and won't boot. So there are some challenges there in doing a direct migration. So at least as far as I know, the plan is that if folks want to get onto Bhyve, they should provision a fresh instance. And the new CentOS and Ubuntu images have the CloudInit updates to do their proper network addressing via the metadata service rather than that DHCP shim. If that answers your question.
Yeah, it does. Thanks. So is this deployed now? I mean, can customers start doing provisioning on Bhyve or not quite yet?
In terms of the JPC, I think reboots are still required, and I think that functionality is hidden, essentially. We have some on-prem customers that have wanted Bhyve, so they have kind of updated their machines so that they have a new enough PI to run it, and are provisioning workload that way. Certainly, folks in the SmartOS community are already using it. I use it for test stuff. There are some additional limitations in terms of, KVM, I believe, used C BIOS to boot, I think. Someone correct me if I'm wrong on that. For Bhyve, the thing that was in use in terms of providing a BIOS-like experience is the UEFI ROM. So we build a UEFI ROM that has the compatibility support module, built into it, so it can boot kind of BIOS-like images. That's how we boot the CentOS and the Ubuntu, the Linuxy ones. But the CSM in that ROM is extremely limited. So I, for example, like using iPXE to boot lab stuff rather than have to copy to super slow PCFS if I want to update the PI for a SmartOS system. But unfortunately, iPXE running under UEFI and CSM, the CSM is not sophisticated enough to allow iPXE to query the PCI devices on the system. So iPXE isn't working, as an example. Windows, we had issues with, we needed to do the Windows install via VNC, via the frame buffer. Similar there, the CSM didn't have like a VGA BIOS that it was presenting to the system. So if you look at VNC on a Bhyve instance that is running the CSM, like running one of the Linux images, you'll see nothing on the frame buffer. There's just nothing there. We interact with on the serial port, which works just fine. The Windows images, we're using a UEFI ROM, which is UEFI only, none of the CSM stuff. And the folks in the FreeBSD side of things wrote a UEFI frame buffer driver so that VNC works, the mouse works on the console. So that's kind of a caveat for the Windows images we have, that right now they only work in UEFI mode. The downside to that, the kind of the Bhyve compatible images for Linux and things work on both KVM and Bhyve, because they're getting their addressing via the metadata service. So on KVM, rather than using the kind of the built-in DHCP, they just grab their address via the metadata service, which is on the same serial port. It's sitting there on TTYB and COM2, statically address themselves, and they work just great. So those are nice because we have an image, those newer images will work on, can be provisioned on Bhyve or on KVM. But in terms of the Windows images, because they're using UEFI, because we don't have UEFI built into our KVM QEMU, those Windows images right now are Bhyve only, which is less than ideal. Other questions? Sorry, I don't have a demo. Kind of disappointed that I couldn't get Zoom to play along. But
Well, Patrick, do you want to talk about the concept of that hybrid images that we currently have?
what do you mean by hybrid images? The ones that work on both?
Yeah. So how does the OS deal with the different requests when it comes to a hybrid image for provisioning KVM versus Bhyve?
In what sense?
Well, I think that's more like the Triton portion of it, but we did do some work to make sure that for the same platform, same platform image, we have a way to tell whether it supports Bhyve or not, right?
That is a piece that I'm less familiar with. I've really focused on the making Bhyve work part.
All right, so I guess that goes to a different JTD. Maybe we can request one from migrants.
Yeah, I think there's kind of plenty upstack that could be talked about as well, but I've focused on things downstack primarily.
Okay, all right.
Patrick, do you want to say anything about future directions at all at this time?
Sure. I mean, in terms of Bhyve future stuff, we're continuing to work with, kind of a benefit of Bhyve over KVM is that the upstream Bhyve developers, primarily folks in the FreeBSD community, are not only willing but kind of enthusiastic that we are working on Bhyve and that we can collaborate there, unlike Linux, where they're kind of, the QEMU folks are doing their thing and the KVM folks are doing their thing. So as an example, right now in Bhyve, there are kind of some statically sized structures that are based on kind of the max vCPUs that you would expect any instance to have. So when you provision a VM, a Bhyve VM, it's based on a static define that we have set to 32 vCPUs. So it allocates system resources as if you might have up to 32 vCPUs in your system, even if you've just got a 2 vCPU instance. Wasting memory, it's not a huge amount, but it's kind of less than ideal. And if our customers are asking for larger instances, like, if they buy one of those new, you've got, I don't know how many cores you can get on a top of the line Xeon these days, but if you want to use a significant portion of the box, we either need to cut a PI to push that up, right? If you wanted 48 vCPUs, it kind of makes it difficult to have a PI that works both for the large instances and the small instances without wasting memory. So one of the things we're working on right now is making allocation like that dynamic, and the FreeBSD folks have been kind of receptive to our input on things like that. Other things that are kind of specific to us right now, there was, in order to get Bhyve to run on Illumos, we had to kind of write some shim layers in terms of like Bhyve on FreeBSD expected the FreeBSD VM system to build the EPT structures for the guest's physical memory paging, things like that. There are some areas there that we could stand to go back and kind of improve that were kind of hacks initially. They work. They work just fine. It's just things to clean up. Other things there, live migration is one that a lot of folks are interested in. There's some efforts on the FreeBSD side in terms of looking at what would be required for that. I suspect that we'll be looking more into those kind of things. On the FreeBSD side, they have support for AMD, whereas we've not finished that porting effort yet. So that would be one, especially as AMD's EPYC Zen chips are coming out and seeing more popularity. We might see more demand for that. So it'd be nice to get AMD support kind of at least at parity with what's on the FreeBSD side, and then look at, things like the APIC virtualization, if there are things that could be improved there, because I think certainly for us, all of the effort has been in making the Intel side stable and high performing. So I think there's still quite a bit of work that could be done on the AMD side. I don't think I've missed anything. If other folks want to chime in about what we've been working on, those are things that come to mind. Other questions? I don't see anything in MIB. If that's it, I think we can wrap up. No one else has queries? Sorry again about...
There's a question on MIB.
Has FreeBSD taken any patches from us yet? That one's complicated. We're still kind of at an impasse around copyright attribution. That one's still kind of a sticky point. I hope that we can come to an agreement that allows us to more easily upstream things into FreeBSD. But I don't think they've taken anything from us yet. So for folks that want to play with Bhyve, unfortunately, the hardware requirements are slightly higher than KVM. We require Westmere or newer. Certainly, I think some folks have been running this in VMware. I've been doing my testing on hardware primarily. But if you have a Westmere machine or newer, you can spin up. If you're going to be doing something in Linux, I would grab one of the. I think we have images out in the October timeframe that should have the CloudInit fixes in them, so that they come up and address themselves on Bhyve. Kind of SmartOS on SmartOS is another focus. Right now, there are some hurdles with the Viona network driver doesn't properly hook up promiscuous support, which is what the guest needs for when SmartOS creates a zone, for example. That zone's going to have a MAC address that doesn't match the MAC address on the NIC. So if you don't have Promisc turned on, you're just never going to receive any of the frames for that guest, and it's not going to have networking. Josh Kalula has a patch out for that. I believe we're going to try and get that hopefully kind of in better shape. We've also made some improvements to the SmartOS VirtIO network driver to make that kind of faster and better, so that hopefully we can start using SmartOS and Bhyve and enjoy some of the performance and do some dogfooding there. But in terms of if you want to play with Bhyve, I wouldn't suggest SmartOS as your first guess. The experience there is a little weird. But if you have to do something Linuxy, it works pretty great. Anything else? All right. Well, thanks for your time. Sorry again about the lack of demos. Yeah.
Thank you, Patrick.
Thanks, Patrick.
Appreciate it. Thanks.